So today we will build a custom AI chatbot using OpenAI API. In this demo, I will show you uh, the notebook only. I will not execute anything about using these tools to generate this kind of chatbot using radio. For example, here I use a data set about the food scrapping. I'm asking general questions about what kind of food scraps are nearby or where is located some kind of place. Because this information is not present on GPT 3.5, we have to augment the data set of knowledge of GPT to answer a specific question, because the advantage that we have is that the LLM is going a good job, but it doesn't know everything specifically in the kind of problem that we want to solve. So here we are using two kinds of techniques, or one kind, but the other you can use any other framework of vector database. The first one is retrieval augmented generation. That's the main focus on this video. And also we're using a vector database, not a vector database, but we're using pandas as a vector database. Usually you don't use pandas, you use LansDB, Chroma, or Pinecone, any other kind of vector database. Now let me explain how this problem is tackled and which kind of data we are using. Okay, I made a simple diagram to explain everything in a short way. For example, we start here with a short question or any kind of question. So, for example, how do you like pasta? And here you have your vector database. The first thing that we need to do is, for example, embed the vector database, that is using a language model, and for each kind of, let's say, sentence, we represent that token list or word list uh, into numerical representation. And we will do the same for the question. The next thing, or the next part of the process, is to find the cosine similarity between our question and the vector database. But we are not interested at all of the cosine similarity. We are interested of the cosine distance. So the less the distance between the question and each one of the line of the embeddings, the more related is with the information with the question. And finally, we will sort that vector database with the most relevant content in the way from less to the to the best answer to the worst answer. Finally, we got this kind of, let's say, database with the text and the embedding and the distance. Finally, we construct a prompt based on the initial question and the relevant content. For example, this one's very hot, spicy because with sauce. We insert this information to GPT 3.5 or any kind of model of text completion that you want to use, and get a better response than the default one. So we will be comparing the default response of GPT-3 or any kind of other completion model that you want to use with the response of our augmented dataset using retrieval augmented generation. So if you understand that, I will pass then to the next step, explaining some parts of this issue. So here in my data folder, I have this 1, 2, and 3 database, let's say. This is the food scrap of New York, This is fashion trends, and those are character descriptions. If you want to, you can check what kind of information is inside the dataset. I use, in my case, the food scrap because I think it's a more general problem and that can solve any kind of uh, issue in the world. For example, each one has the necessity or the need to go to a food scrap to put or a trash can to put your your bag of disposals, for example. That's why I selected this one. But you can use this one or this one. The other ones are the text that we're using in some examples. I will let you know where are the examples. And this is the embeddings of the food scrap that I use, I think. Or I made it by the fly. I think this is for the examples. Okay, now let's start explaining a little bit more. You can read the documentation, but practically here is the thing that I told you. We'll start with a question, start with the most relevant content. We'll use a custom prompt, and we get a custom answer. So the first part is to prepare the dataset using embeddings. The next one is using these embeddings on the question to find the similarity, and then the distance. That is the difference between 1 minus the cosine similarity. This one. So if are identical, all the vectors have the same cosine distance. If not, if are opposite, then are pointing in a negative way. And if are unrelated, the cosine distance gives 1. Next, with that question and relevant information sorted, we present to the text completion model the custom prompt, and with the custom prompt, we will get the custom answer. That's everything that is done here. As a bonus, I made a simple Gradio app. You can use any kind of dashboarding framework that we want to use, Gradio, Anvil, Streamlit. But let's start to explain the application. So let's put it on 100. The first thing is to use these utility functions, the get embeddings and distance from embeddings using OpenAI. I don't tell you, but this is the requirements for what we are using this in this video. We are using an old version of OpenAI API. Next, you have to put here your OpenAI API key. We're using the embedding models as the text embedding ADA 002, and the completion model, you can use any one, but I'm using text DaVinci 003. This batch size is for loading, in this case, 128 messages to embed, because we cannot do all throw all text to the embeddings model. It will respond with a rate limit error, so we'll do in batches. In my case, I do in batch of 108. You can put a little bit more or less. You have to test. The first part is test data wrangling. We will use the food scrap dataset, and we will drop these columns. Why? Because, well, I inspected the dataset previously, and I detected that these columns are not needed. For example, here it's a kind of numerical information that is not human understandable, so I decided to drop it. So I decided to drop it this ones, the location point also, because we have latitude and longitude on the data set. The object ID is not relevant, and that's why I drop this kind of information. So you will end with this data set with the borrow, the first graph assigned, the location, where it's hosted, any kind of relevant information for me, I leave it in the dataset. Next thing, I made this ugly transformation to, in that case, transform some null values to string, and also put if they are missing or not, to consider it on the completion and the embedding. So just it's a simple transformation of the NaN values. Why this strange representation? Because if you want to check if something is NaN or not, there is a way that I am presenting here. If you compare some variable to some variable, and if not present, then it's considered a NaN. So that's just everything here in the code. Just only to let you know what I am doing here. So now we have all the rows or observations not null and are all of the kind object. I will rename the columns just to get a better understanding of each column. For example, NTA name, what's that? Okay, is the neighborhood tabulation area name? Oh, that's a better representation, just to feed to the model and for the user to understand a little bit better. Next, on the data set, I made a text column. For each one of the rows, I made a text column that will put all the rows all the columns in one single column. For example, the column text have in this format the borrow, the neighborhood, the food drop site, and then for each one of the observations, we will have that in that manner. And this is just only to see the representation over a data frame. It's not more than that. I'm renaming the data frame using only the text one. We put the text to the text CSV file if you want to load it directly and to not do preprocessing again, for example, in your application. And this part is doing the embeddings. As I told you, I'm doing in a range of batch size of 128. So for each batch size inside the document, we will create an embedding of the text data frame and put it over the embeddings array, and this embedding array will go to the data frame. So here you have the output, you have text and the previous data frame and the embeddings, and we put out the embeddings. Next, we will now have a function to get the rows sorted. For example, regarding to the question and the data frame, we will make a call for the distance from embeddings function to sort it in the most relevant to the less relevant over the data frame. And in the end, I just copy this data frame information regarding with the question, and we will sort it in a ascending way, so from less to lower, so to higher, sorry. The last one, this is the most relevant, for example, of the question, which drop off will occur on Staten Island. So if we try to embed this thing and then do the cosine distance, we saw that this is the most relevant content, this one the second one, and so on until the end. In the end, we will have 576 rows sorted. Next, for the next question, as you see here, there's different results for different kind of questions. So we are just looking if our function is sorting in an efficient way the embeddings dataset. The next is to prepare a custom query. For example, answer the question based on the context below, and if the question can be answered based on the content, say I don't know. So we will put the context and the question. The question will be any these questions that we'll specify here. The context is the representation of the result of the embeddings sorted by cosine distance, and it will answer the question based on the context. So here we test the default prompt and the custom prompt. So answer the question based on the context, and the context is from the most relevant and the less relevant. As we saw here, we'll try to complete the context with near probably 4,000 tokens, because we had to measure the number of tokens of the question, the number of tokens of the default question that we'll be using to feed the content, the token count of the context, and this token count here. So if you sum all the token context here, probably are near or similar to 4,000. And this one answers the question based on the prompt that will be feeded. For example, answer the question: how many food scrap drop-off happen on staff at Domino's Park Hour in Manhattan, and blah blah blah. And the response is: 2 New York City food scrap drop-off locations hosted by staff Domino Park and Manhattan are in Domino's Park, and so on. Another example here is what happens if I use the default prompting. For example, if I feed the same question or other using no embedding and no GPT completion, and just feeding the data frame. For example, the default prompting here, it will tell us that there is something a little bit odd. If you compare the response, you will see. So the first question is food scraps. This is just, for example, if we are trying to demonstrate the performance, what happens when we use the default prompting with the embeddings model. So the first one is the question with the default prompting. I think, let me see, default response, yes. So this is the question: food scrap drop-off size between Friday and Saturday, and this is the first response of the default response. Food scrap drop-offs are typically open during normal business hours throughout the week. On Fridays and Sunday, many community. So if you see, there is not much information relevant to that what we need. If we use your question answering by embeddings, you will see by the given prompt, you have, okay, Tompkins Square Green Market at Sunday 8 a.m. to 5 p.m. Kew Gardens is more relevant, the information solving the problem using retrieval augmented generation than using the default prompt, obviously, because we are feeding the data sets, we're feeding the network, the LLM, with relevant content based on the knowledge and based on cosine distance. So here, a second question, you see there's not much relevant information about that, but if we use the embedding answering kind of question, we'll see a better response. In the end here, there's the a little, for example, interface over the notebook to test the capability of the model using answer question answer based on knowledge base. So if you want to see also the Gradio app, you can go here. The Gradio app is pretty simple. We'll use the model, the embeddings. You do not have to calculate every time. I use the embeddings itself. Find this kind of functions. This is then the information that we start to construct over the embeddings and the distances. This is the default prompting. It's kind of the same of the previous notebook, but in the end you will see that we will be using the notebook with Gradio. Finally, the prompt, just testing, and here the Gradio app. So the Gradio app, it will do this thing. And if you want to check the Gradio app file is here. You will use this class that I made for using simply Gradio, the embedding chatbot that is on the helpers. You use specify the models, the kind of tokens, and the embeddings path. You will start to see the interface that we saw on the beginning of the video. This one. Okay, how much is it? And let's see the shutter. The shutter have all the functions that we discussed on the notebook. Just to keep it simple, here's the completion for using the OpenAI completion model. And returning to the original file of Gradio, you see that it's a pretty simple application, but it's based on the class here. So that's all. I hope you understand what is retrieval augmented generation, or knowledge-based, sometimes they call it that way, over OpenAI API keys and using the embedded model. Remember to check the documentation. I made, for example, a personal application using the API on my work, and I had to change the IP calls. So keep in your mind that this is the old version. So if you try to install OpenAI package and use this notebook, be sure to use the requirement file. If not, change all those functions to your application. But I will let you know that these functions here are probably not anymore. For example, in my case, it get a little bit problematic to use the distance from embedding. I had to make a function to do that in the new version of OpenAI. And in the documentation, it's pretty clear that you can use any other kind of functions like the pairwise library in scikit-learn to calculate cosine and similarity and then cosine distance. So that's all. I hope you like the explanation, or the brief explanation of the retrieval augmented generation here. I think if you see again the diagram, you will understand anymore what we understand. Sorry, not anymore. Understand in the facts that we are discussed over the notebook. So that's all. I hope you like the explanation here, and thank you.